The Fermi Paradox. You know, the universe is big and old, and alien civilizations should be everywhere, and yet we see no evidence for them. Where is everybody? Now, people have come up with responses to explain the Fermi Paradox, and there are many. And in this video, we're going to go through all of the major classifications of the Fermi Paradox and rank them from S to D. Now, I'm not going to do this alone. I brought in two of my space communicator friends. Dr. Moya McTeer, she is a podcaster, astrophysicist, and hosts several very successful podcasts. Her Pale Blue podcast is sort of vying for the top place in the astronomy category on iTunes with Universe Today podcast. So it's very good company. And then my other co-host today is Dakota Tyler. He is a PhD student at UCLA. You probably saw him fairly recently. He's a public speaker, a science communicator, but also a researcher in exoplanets. So he thinks about this a lot. Now, this is a lighthearted conversation. We have a lot of fun, a lot of hot takes. I'm sure you're going to disagree about a bunch of them. And so if and when you do, go ahead, stop the video, put in your comment, let us know why you think we have either under or over ranked one of these. And you'll be the fourth part of this video, joining this conversation to finally rank all of the Fermi Paradox responses. Let's jump in to ranking the Fermi Paradox with Dr. Moya McTeer and Dakota Tyler. All right, Dakota, Moya, it's good to see you guys.
Hi, Fraser. Good to be here.
Yeah, great to see you.
So I have sort of drawn upon your strengths, I believe, and between the three of us, we will be able to just fundamentally answer the question of why we appear to be alone in the universe. That, you know, once this process has completed, this will be settled science. Hundreds of years from now, people will look back, they will say, right, of course. Remember that conversation that the three had about the tiers of the Fermi Paradox answers? Why are we even talking about this? Anyone from this point forward who wants to have an argument about this on the internet could just refer to this video. It's done. Everything is going to flow nicely in here. No, of course not. And I welcome your spirited debate in the comments below. So let's start with the zoo hypothesis. And this is the idea that, in fact, our perception of the universe is not as it truly is, that there is advanced civilizations around us, and yet they are manipulating our view to the cosmos, possibly for some awful reason.
Like actively manipulating our view of the sky so we can't see that other people are out there, so that they can
see what they
us.
Want us to see. That's exactly right. And so, of course, we don't see anyone because they don't want us to see anyone.
That seems to me like it would require an awful amount of power and technological cunning. And I'm not very convinced, Dakota. I'd love to hear your thoughts.
Yeah, I didn't. So when I've heard of the zoo hypothesis, it was more so of maybe alien researchers are studying us, but not interacting. But this one where they are actually like concealing the universe from us that seems pretty inconceivable for me. And also, like, why would they? Like, what would be the point? Seems like you could do that on a much smaller scale, like in a lab or something like that.
Mm-hmm.
And we'll get to that. There's a version of it that definitely incorporates that. I mean, I personally, of all of the Fermi Paradox ones, I find this one actually marginally compelling. Only because if they are able to control it 100%, then what the reasons are, like if we don't understand what the universe truly is, then we're approaching this question of our place in the universe from a flawed understanding of the facts. And so, you know, what are stars? What are galaxies? What are all of that? None of that is real. Right. Or maybe it is. And yet they're able to hide other parts of the universe from us.
Yeah. If you get to that, I think that it is one of the more reasonable scenarios. But I think that if point that they can actually control our entire perception of space 100%, that to me seems beyond the point where I'm willing to suspend my disbelief.
And that, like, unless they're magic, that there would be some crack in their technology. And at some point we would come up with a method to see through some part of this.
Exactly.
Right? Because we look out now with the James Webb Space Telescope, basically as far as you could possibly see. And we don't see like physics breaking down anywhere. It seems like everything is consistent. There isn't like some flaw in their holographic projector. It's like all working perfectly across the span of the entire universe. That's I'm not aware of any programs that work that well.
Right. Well, I mean, that's just what the aliens want us to believe.
That is what they would want us to believe. You're right.
Yeah. All right. I figure you've had your chance. Have you guys formulated what you think is a tier on this system?
I'm giving it a C tier.
Whoa. Yeah. Go.
Whoa.
I respect that. I'll give it a C tier.
Wow.
I think there are some more ridiculous things on here.
All right. I'm gonna allow it because you guys agreed, and that way I can't sort of come in and just decide for you. But I think it's more compelling, and than almost any others that we're about to go through. I find, it's my personal favorite.
I'm sorry, Fraser.
My favorite. No, it's fine. It's fine. It's not
we
my favorite.
We can give it a
favorite.
C+.
No. A C+. Sure, fine. But it's indistinguishable. It's a rounding error. All right, let's move on. So a version of this is the prime directive. And so the aliens are not hiding the universe from us. They are aware of us. And just like Star Trek, they are attempting to interact or observe us in a way that doesn't harm our future growth. But it does, there is some overlap here because it is going to sort of flow into, there's going to be times when they're going to have to hide their existence, their warp drive signatures as they're passing through the universe. So it does overlap a bit with the zoo hypothesis. Moya?
Yeah, I'm much more compelled by this one. I think that it is a lot more reasonable that there would be aliens out there and they are waiting to see how we will evolve technologically and culturally and biologically before they step in. And those small signatures of any sort of faster than light travel capability, those are easier to hide than our entire view of the night sky.
Yeah, I have to second that. That makes sense to me from a scientist perspective. I'm really into biology and ecology. And oftentimes when you are studying or, you're aware of something, you do want to kind of see it from a distance. You don't want to get in and start messing around and causing destruction or anything. So that's a little bit more reasonable to me, at least like on the technological side.
But don't you feel like Star Trek already showed you how this theory is flawed, that Captain Kirk never saw a prime directive that he didn't want to violate? That as soon as he could, right? He was wooing alien women. And so that, are you going to get some kind of monolithic agreement by all the aliens to never interact in any way, shape, or form with the natives? Or are you going to get individuals breaking the rules, they're going to see something awful happening to somebody, and they're going to go, I can't let this stand. I've got to jump in. I got to provide the cure. I've got to rescue these people from this erupting island, whatever it is.
Oh, yeah. Yeah, there will be the Kirks out there. But I think either the actual Federation is really good at weeding them out, so there aren't as many of them as we would expect, or aliens just find humans ugly, and the actual Kirks don't want to come and help us.
Yeah, I could see that. We also have to, I think, be careful, especially when we talk about sci-fi, with projecting our ideas, our feelings, how humans have evolved, our tendency on other species or whatever, right? Because there's so many things that has gone into the development of our emotions and how we feel about things, tracking back millions of years to our ancestors surviving in the wild. And maybe an advanced species doesn't have some of those problems that we still have. Maybe they're better, or they're like different altogether, or maybe they're just much worse.
And there is a that's coming shortly. We're going to have both flavors of that. But I guess for me, it doesn't feel like you could be monolithic about this, that you could have one that is perfectly peaceful and transcendent and only wants what's best. You're going to have one that is mischievous and wants to get involved, and one that wants to save lives. And that unless you can't expect them to all behave the same. And yet it's those edge cases that will reveal themselves to us.
Mm-hmm. I think if there was some great threat or incentive that they could all align. But no, I think you're right. I think that is one of the reasons that this is not the most compelling argument against the Fermi paradox, but it does better than the zoo hypothesis for me because it doesn't rely on as much tech advancement.
All right. Then put it in a number, a letter, I guess.
I'm giving it a B.
I'm going to give it a C, a super C.
Whoa.
C still.
All right. Well, then I'm going to have to jump in here, and I'm gonna push it up to a B because I can't imagine them all doing the same thing, all getting in line. That the diversity of the aliens is the thing that would show the cracks, but at the same time, it's less difficult to control the entire perception of an entire universe. But so I it's not the best for me. All right, let's move on. And I know, Dakota, you've covered this quite a bit recently, the simulation hypothesis. And this is a flavor of the zoo hypothesis, but essentially we're just living in a simulation. And so we just see what the computer simulation is programmed to show us. And so if the computer simulation doesn't include extra civilizations in the universe, then we don't see them. And it's very easy. You just civilizations equals 1. Done. In the code. So Dakota, what is your argument, I guess, for against the simulation hypothesis?
Yeah, so it's not one that's very exciting. If it is true, that's kind of a bummer in my opinion. But I think that for the simulation theory, the thing that we have to realize is that when you build a strong computer or whatever the computer is doing, it can't be doing more than it has the ability to do. It can't be producing more information than the computer itself has. So when you talk about simulating every atom in the universe, for me, you have to have a computer that's basically a universe, which doesn't that doesn't make sense to me logically. So I would say that, if that did happen, I do think that you could probably do a simulation that created beings with consciousness. I think that may even be possible, but it's far-fetched to think that there's a computer that can simulate an entire universe. And it almost seems like a waste as well. You made this whole universe, but only simulated species on one planet. That doesn't, as a scientist, I wouldn't do that. I'm trying to write a bunch of papers. So I'm putting them in maybe in different quadrants all over the galaxy or the universe, but
you need
I wouldn't
control
just
groups.
do one. Yeah, right. Exactly.
But how do we know that the reality that we experience has anything to do with base reality?
Are you Plato? I mean, people have been discussing this for 2,000 years.
Well, exactly.
And I get the urge, but at the end of the day, we have to recognize that we are humans with brains who experience the world through electrical impulses sent through those brains. And if I can't trust those electrical impulses, or at least the proxy of the universe that I have constructed around them, then everything else crumbles into not mattering. So I would rather trust the electrical impulses through my brain to an extent. And I get freaked out about the fractal implications of a simulation hypothesis, of a potential simulated universe full of other simulations that could eventually get good enough that they can simulate entire universes. And that just makes my head hurt. So I personally don't like this hypothesis.
Right. I mean, I think it's really important to distinguish between just the simulation hypothesis and, because it is, you just can't falsify it. It is effectively existence and reality, and there's no way to know that. If you not only are you determining that there are no aliens in the universe, you're also determining that reality itself isn't real, and that's a deeper problem, right? I'll be like, oh, I'm concerned about aliens, but actually I'm really concerned that reality isn't real. I'm no longer concerned about
it. It almost seems like it might be falsifiable, though, because if let's say that we are in a simulation and there's only life on Earth, that means that the physics around Earth is literally different than the physics in other places. And so you would think that you could look out into the universe and maybe you would see, maybe there's no carbon in other places, right? Like something that is required for life isn't there, or the chemistry is behaving differently somewhere else that's preventing whatever happened here to happen there. So it does seem like there should be evidence. I don't know if we like have the sensitivity to detect something like that, but if life happened here through like some physical program, it should be different in other places, I would think.
Yeah, so that's really interesting. I really like where you're going with this, because essentially that if we don't see the conditions for life in other places in the universe, it almost feels like the simulator's got their thumb on the algorithm and is driving Earth to be the only place that life can form. But if we do find the conditions for life, and we do find eventually life everywhere, then it feels a lot more like it's just some infinitely randomly generated universe. Which sounds like a computer term again. But anyway.
Once you get stuck in it, it's hard to leave, like once you agree to those base tenets. But no, I like Dakota's original point that it just would require way more power than is feasible.
All right. I'm calling it. Give me your turn. Dakota, you get to start this time.
I'm gonna go ahead with D for this one. I'm gonna stick it way down.
Yeah.
I was going to give it a C.
Yeah. I concur with D. And actually, it's not Dakota's original take. I think it's the point that he made second, which is that you would see a universe that was being simulated to not have any other alien civilizations in it would look very different from a universe that was more randomly seeded to just that just is real, right? And actually, I find that a really compelling argument. So while we may never know if we live in a simulation, we can use the simulation hypothesis to sort of figure out why there aren't aliens in the universe. So I think that's great. All right, let's move on to a science fiction concept. This is the dark forest hypothesis. And this comes from the three-body problem, which is now a Netflix show, but is also a very famous piece of Chinese science fiction. And the gist is that the universe is a horrible and dangerous place, that there are threats everywhere, and the absolute best strategy is to just stay quiet and listen, lest a more advanced civilization is going to find you and wipe you out of the universe.
Yeah, so if we really are just thinking about the nature of animals and intelligent animals as we know them, I see why we go there. It still feels kind of like a human projection, but easily, if we came into contact with any species that was faring through space, for sure they're more advanced than us already. And that's, would pose a serious threat in any sort of conflict. So, it's I think more realistic than some of the other ones, but it's still not super compelling because we should see at least evidence for that big bully species that's out there.
That part. Yeah. I mean, the universe is kind of a dangerous place, and there are a lot of places in galaxies where there are astrophysical things that can hurt you. But the fact that they would be trying to keep themselves a secret implies that it's active agents that they are hiding from, these bullies that Dakota was talking about. And yeah, we would see evidence of them, because if all of these different species around the universe are hiding from something, they have to know that there's something to hide from. It's not a base instinct that I think we can assume every living creature in the universe will have. So then where is that visible bully that everyone saw and reacted to?
Yeah. And we are at the point now with James Webb, we're about to be able to image the atmospheres of exoplanets, maybe detect potential biosignatures. We could detect technosignatures like chlorofluorocarbons. The square kilometer array is coming online in another decade. That's going to allow us to eavesdrop on air traffic control systems within hundreds of light years of us. So you can imagine some advanced civilization building a telescope that is 10,000 kilometers across, positioned at the solar gravitational lens, and is watching us sit outside drinking coffee from 100 light years away. It feels like the technology, although we're right at the cusp of developing that technology, imagine 100 years, 1,000 years, 1,000,000 years of development. What could we perceive in the universe? How do you hide from that level of technology?
That's a really good point. Obviously, I'm talking about, the evidence that we see, but I'm looking at best with like 10-meter telescopes for planet sizes and masses, not even really a detailed analysis of the atmosphere. So yeah, maybe in 1,000 years, it is easy to detect these sorts of things. That's a good point, because we don't know what we don't know, and we can't see what we haven't built a camera to image yet. So
So it's like if we can see, if we're about to be able to see them, they can already see us. So we can't hide. They knew about us the moment bacteria started pumping the atmosphere full of oxygen.
But also, not everyone would react by hiding. Like, there would definitely be some who would react by learning how to fight back in this scenario. So I think one of the major faults here is assuming everyone would play dead, essentially.
Well, I think from a game theory standpoint, because there are giant delays in communication, there are tens, if not hundreds of years of delay in communication, that game theory predicts that things tend to push towards aggressive and not peaceful interactions. And there's some interesting papers that I've read that sort of go into this. We covered it on Universe Today, but that's the gist. They had some large language models simulate interactions between advanced civilizations of different personality types through kind of game theory interactions, and found that they tended towards negative interactions, that even fairly positive personalities, because of the sort of game theory implications and the potential downsides of being open and honest to a completely unknown civilization causes risks, you tend towards being closed down, and that tends the interaction to go negative. Like with humanity here on Earth, we have these really quick feedbacks back and forth. We can talk with someone and get a sense if they're on the level. They can do things that we can see if their actions match their words and so on. But with longer and longer delays, with less in common, it's really hard to build that common ground in a way to build an interaction that lasts the test of time.
That makes sense, because you would tend, in that uncertainty, you would tend towards maybe defensiveness.
Right. Exactly. I disagree.
That makes sense.
I disagree hard. I mean, I think that we're all agreeing on the same major point. I just think that more people would fight back than hide.
Right. They'd be like, we're not going to live in quiet. There's too much to lose and so much we could gain if we get out there, and maybe we have to face the threats.
Yeah, and I think there will be, given the diversity of planets and amazing diversity of species that face this same problem. And some species will be inclined to hide. Maybe they evolutionarily adapted to be more cooperative or to be more skittish, to flee instead of fight. But there will be some species that evolve to fight first. There will be some species eventually who actually are bigger and stronger or have other advantages over the bully species. So I think it won't all just trend towards towards playing dead.
Well, what if those fights are almost instantly, completely destructive?
Like if the bully species can just destroy entire planets at once?
Or even if we, Or
send them a bad idea. Mm-hmm. That's the method that I love the most, the creepiest one, is that you transmit a bad idea that then a civilization uses to wipe themselves out because they can't help themselves. Here's a machine that will cure all disease on your planet. Here's the schematics for a machine that'll cure all disease on your planet. And they're like, should we build it? Shouldn't we build it? I don't know. They build it. Everybody dies. Done. That was easy, right? And I find that scary.
That's
there was
terrifying.
You can sort of think about the levels that you would have to go to take out another civilization. And the easiest one is just a piece of information. Then you're going to have to send kinetic impactors, and, it gets worse and more energy intensive. And if you're going to try to cover all your bases, Yeah, you just send bad ideas, bad memes to everybody. All right, vote.
Familiar.
Choose, but choose wisely. All right, Moy, I'm going to let you start on this one.
I'm giving it a D.
D.
Yeah.
Dakota?
Yeah, I think I'm going to go ahead and have to give it a D as well.
100% agree. Yeah. This, I'm so sorry for the sci-fi fans who find this scary and compelling. I just don't find it compelling.
Yeah, it is scary.
Oh yeah,
just not
great
compelling.
science fiction books. Yeah, when they cover it in the Three Body Problem and the Dark Forest, the book that has its name, it's terrifying.
Mm-hmm. I would be more,
and not just how awful it is, but how easy it is to just enact this on the people that you find.
Yeah, I would feel better about it if it were actually due to astronomical dangers, like if it actually was just about galactic habitable zones.
We're about to get to that then.
Great.
So let's move on. So the next one is the Great Filter. And this is the theory provided by Robert Hansen. The gist is that there is some event or combination of events that are filters that life must go through to be able to move on to the next step. And you can imagine like just life first forming and then multicellular life and then intelligence. And if, each time you have 10,000 life forms, but only 500 reach multicellular life and then only 30 reach reach technological civilization, and that there are then future filters ahead of us that we have yet to reach. And that though it's that combination of the past filters and the future filters that winnow all civilizations down to zero. And where we stand in the timeline of history, we've passed however many of the filters we already got through, but more stand in front of us. And if the population of civilizations in the universe is anything to go by, our chances aren't great. So Moya, what do you think about the Great Filter?
I like it more than anything we've discussed so far, because there are, like I said, astronomical events. There are supernovae explosions that you want to be far away from. There are big gamma ray burst events that you want to be away from. You don't want to be near a place in the galaxy where there are a lot of stars around that could have gravitational interactions. And we all know that individual stars have their lifespans too. So I think looking back, there are a lot of filters that are common to get through, like it seems the ingredients, the building blocks are common. Having some sort of radiation that can spur genetic variation is common, but so is stellar expansion and death. So I think, eventually there's a time limit on everything.
Yeah, I agree. There's the Great Filter. I mean, even just thinking about life on Earth, for us to get to where we are, to be online, doing, speaking through radio waves, we needed certain animals to develop and, expand, and then we needed them to go extinct at these sort of periodic intervals. And each one of those events was like devastating for life and pushed life to the edge, but it allowed for a new species to come, or it allowed for mammals to come. And it's like, there's so many variables in there. I can see tons and tons of bottlenecks, and there's no reason that those bottlenecks are going to stop, now that we've gotten right here. I mean, getting through the Cold War may have been a great filter bottleneck that usually if a species develops nuclear weapons, they quickly use them on themselves. And I mean, that could still happen. That could happen tomorrow.
Mm-hmm.
Yeah, and you can imagine the few that we face right now. Well, we have probably 3 separate ones that we're looking at right now in terms of artificial intelligence. We're looking at potential for biological weapons, and then whatever is like the future of big science. Like there could be some science experiment that you turn on the super duper large hadron collider and it just collapses the universe into strangelets or whatever. We don't know. The part that I find hopeful is that maybe we did it. Maybe we passed them all, right? And we're out here on the other side of all the filters. We're done. And because it feels like the rest of the universe is now in our grasp. We are sending humans into space. We are building robots. We're learning to live on other worlds. Once we've expanded into the cosmos a little bit, it'll feel like we're probably through that filter. But But on the other side, there is this understanding that you have to think about that that it affects 100% of civilizations. That because we don't see any civilizations out in the universe, whatever the great filter is, it's coming for us all.
Mhm.
And you can't predict it. You can't prevent it. You can't avoid it. Because if you could, then we would see the examples. We would see the ones that pass the filter.
I mean,
And
can
so-
like 3% get through? I feel like
Then-
it doesn't have to be all or nothing.
Well,
But-
if the 3% get through and then they build their self-replicating robot probes and explore the universe for 1 billion years, then we would see their results, those who got through.
Okay.
The example that I would sort of like to give is like spiders. Like we're not, and we'll get to this later on, but you're not looking for spiders. The spiders that survived all of the ecological sort of, evolution, Darwinian adaptation, and so on, they found their way to you. I just watched one crawl across my desk just a second ago, right? He's here. He did it. I didn't have to go looking for the spider. The spider was successful and showed me evidence of its existence. So any version that could be a potential filter for me, whenever you say them, then I think that can't be the filter then, because you're literally predicting it. That gives us a chance to avoid it. Therefore, and so the kind of the cosmic horror of the great filter, in my position, is that whatever it is, it affects 100% of people and nobody sees it coming.
Or they see it coming, but they can't stop it. That to me,
you can't stop it.
Yeah. I'm glad you feel a lot of optimism. I feel like we are Icarus, near the top of our
When did
flight.
I say I had optimism?
I sensed a hint of it. Maybe I just misunderstood.
My PDUM is pretty high, but yeah.
It sounds like you're optimistic that if it is true, we just don't know what it is, which is like, I guess, like a blissful optimism.
Either we're done, either we already hit the finish line and now we're on to the next level. Too bad, so sad for all the other suckers that didn't make it this far. Or the ones coming next are the ones that even we can't avoid.
So I think that's possible. But I think that one thing that will remain a filter forever is us overcoming our like evolutionary past, all of the negative tendencies that we have that we're like struggling through society today. That seems like something that you can always be aware of, but you can never like avoid. Like we can't strip ourselves of the way that we've evolved to be for millions of years. And even in 1,000 years, genetically, those humans are going to be basically the exact same as us. So they're going to have like all the same problems. So I see that as being like a predictable but unstoppable filter.
Yeah, it's a combination. Like you just roll the dice enough times, and they add up to not making it out into the universe. Yeah. All right. Let's hear your votes.
I'll go ahead and give this an S tier.
Whoa.
This to me is at least in part true.
I am strategically saving my S tier for one that is very similar to this. So I'm giving this an A.
I'm going to concur. Mostly because I don't want to imagine that we can't find a way through this. Like, I don't like that answer. I don't like that answer that we are doomed like all of the other civilizations that came before us. But I think that's exactly what they said too.
Yeah.
As they face down whatever is the existential crisis. So I agree, but it is high A tier.
Yeah. It's a wishful thinking A tier.
Yeah, exactly. Yeah. All right, let's move on. So the next one is self-destruction. And this is a version of the great filter, but specifically focuses not on the past of the great filter, but on the future, that we are about to do something that will wipe ourselves out of existence. But more importantly, that every intelligent civilization wipes itself out of existence. That's the scary part. And so too will we. And so, Moya, how do you feel about that one?
I think honestly, this is the most likely because I see ourselves headed for destruction, and unless we really do a lot to curb that, to curb our overconsumption and our wars with each other, and like all of the stuff that Dakota talked about, our base human instincts, I think we're in danger. And I think that that could easily get a lot of other species. And there's something appealing to me about it being on the species level instead of on the world level. Like, I was thinking of the Great Filter as something that destroys an entire planet, and self-destruction is like a mass extinction event that leaves the planet and maybe other life forms there that can rise up, but then you're starting back at like zero, so it's hard to get to the intelligent communicating point again.
Yeah, I agree with that. There's this is definitely like the direction that we're headed in. I'm more optimistic than Moya. It sounds like I don't think that we're like doomed to that, but I could see that being a possibility. The self-destruction thing. Yeah. I mean, even look at species on Earth who we assume maybe are not as bad or greedy or whatever as humans. If you release a species into the wild and they're in an environment they didn't evolve for, they're going to decimate that environment. They're going to eat them. They'll like reproduce too much. They'll eat themselves out of existence or hunt themselves out of existence. And it's just a very common thing to do. And we do it in a way that it's like we're using technology and we're changing ecosystems way more than we're aware that we even have the power to do. And we only can try to like catch up in after the fact. And I mean, there's only a matter of time. It doesn't need to be like nuclear war or even climate change. Like there's no telling what things we're doing that are going to, cause untold consequences or unforeseen.
Like what if you gave octopuses fighter jets? Right. Would that work out well for us? Yeah,
it would be entertaining. It would make great TV for a while.
They could control a lot of the cockpit all at the same time.
They do. So
there's sort of like two parts to this. One is, though, I think for it to qualify as the Great Filter, it needs to wipe out. It needs to keep the civilization down until the time runs out, until the sun dies, pretty much. And so even though we may mess this up, then we've got the octopuses, then we've got the whales, then we've got the, who knows, slugs maybe?
Crows. Crows are smart.
The crows, yeah.
The crabs, too.
The crabs, yeah. And everything's got a crab, right?
They're not smart, but they always survive.
Yeah, they're the end game, though. Evolutionarily.
And so, like, to sort of take your depressing attitude about the future of humanity and to square it, like exponential style, it happened. No civilization ever doesn't, like, there's something baked into life that it moves up a technological chain and then wipes itself out, and then another civilization comes along and it wipes itself out, and it happens 100% of the time because nobody slipped through.
I would propose that there's an off-ramp, that when you're on the highway to species destruction, there's an off-ramp to learning how to live with the environment without taking advantage of it. I know that there are some humans, that indigenous groups were very able to live with the land and steward it and take care of it. And I think there are some species that can make that happen with their worlds, but then they can't be like advancing technology and always needing more and more power.
A species like that, what you just described, Moya, wouldn't be looking to go out and like seed the galaxy or the universe or anything like that. So they almost weed themselves out from being found.
Mm-hmm.
Right. But they're also potentially victims for the ones that do.
Yes.
Which, that's like, we see that in, like, unfortunately, how well does that turn out for people? And that's the problem is that we're going to see the expanders, the ones going for it all. We're not going to see the ones who got through the self-destructive phase. And it could very well be that then it's just a matter of time before the super expanders find them and, how this works. Humanity has its history. So, vote.
This is getting an S from me.
I have to put it on the same level as the Great Filter. So A, I'd give it an A.
Yeah. I agree on, again, I think it's back for the same reason for the Great Filter, which is that I can't believe that everybody falls to this. So, but I'm going to respect the S on this one, I think. Because it's and this is Carl Sagan's argument. Like, this was the thing that Carl Sagan was deeply worried about and used as a way of looking at the rise of humanity. And his answer for the Fermi Paradox was that we don't see other civilizations out there because probably they're having nuclear wars. So
I gotta go with my old buddy Carl.
Well, your podcast is inspired.
Yeah,
right?
Exactly. Yeah, 100%. So I got to go with Carl.
Yeah, exactly. Yeah. And that's, I think, pushed over the edge for me. All right. We're first. So intelligent life is common in the universe, but it just hasn't gotten to the point where it has expanded out and made its presence known. And we are, if not the most advanced civilization in the universe, we're right in that line right now. And when you think about just how long it took for heavier elements and molecules to be able to form into the cosmos, there's only been a certain amount of time that the universe has actually been viable for life. The Milky Way has only been viable for a certain amount of time, and we just happen to be first.
Something to this, for the first round of stars, there were no heavier elements, so they couldn't even have planets. And then over time, you sort of like build up the elements that can go into planets and life. And you need like second or third generation stars to get that. So, it is possible that I wouldn't say that we're first. Maybe there's like a lot of civilizations that are at the same point. But I do think that it could be possible that we're like around that range. But then again, even if you like slide the scale by 100,000 years or something, you're talking about a civilization that's so much more advanced in really the blink of an eye. And again, we don't see evidence for that. So it's hard to say that like everybody's in their 2024-ish period, but it could be. It could be. Seems unlikely.
I mean, it's the future, or like that's what science fiction generally shows us, because science fiction is essentially retelling existing stories. But the Vulcans, the Klingons, the Romulans, they're all roughly equivalent. They all reach the same level of technological capability at roughly the same time, as opposed to one being godlike and the rest falling in line. And I think that's that science fiction, just that's how they typically tackle this stuff. So, Moya, what do you think?
Yeah, I think I think they do that because it's easier for narrative. But for the we're first argument, life on Earth formed very early, like very soon after the conditions were present. And those conditions on the universe scale were present a lot earlier than just 3 billion years ago. So I don't think it's very likely that we're the first. I think even before our sun formed, there were still plenty of other stars that had enough heavy elements around them to form planets and make organic creatures, or not.
I feel like it's either like it is a perfect explanation. Like it isn't, like if you think about it, like could we be first? Yes, we could be first. There's no weird, convoluted, complicated machinations. Someone had to be first. It could have been us. And yet the likelihood that we're the ones that were first seems remote.
But even in sci-fi, we often don't imagine that humans were the first civilization. I think they do this often to explain away that all the aliens look humanoid, but in so many different franchises, there's that OG species that evolved and then seeded their DNA around the galaxy or whatever. And so even in our wildest stories, we weren't first.
Yep. All right. Then give me a vote, Moya.
C. It's a high C, but it's a C.
Yeah, Dakota?
I'm comfortable with that. I think it's about a C.
Yeah. I feel like I agree with you, because it just seems unlikely that we're first. But it does feel like someone had to be first. And so for someone out there, that answer is 100%. It's super S tier. But I so rare intelligence. So this is the idea that life is common. It's the rare Earth hypothesis that basic biological life, bacteria, archaea, things like that, it's everywhere, but there's something really difficult about getting to multicellular life that makes it incredibly rare, and technology even rarer than that. And so we may find life is everywhere, but there's actually just no intelligence.
I really like this one. The perfect example is here on Earth. Life started basically as soon as it could, but was more or less single celled for 3 billion years. And only in the last, 550 million years did a complexity arise. And it's like skyrocketed since then, obviously. But for so long, like literally 3.1 billion years, it was just single celled little, amoebas or whatever they were. And that's like such a long time to have no sort of great mutations or no sort of leap into multicellular life. So I mean that's like super compelling to me that it conceivably life could just get stuck in that state before some of these other things Moya was talking about that happens, other astrophysical events, or maybe like a destabilization on the planet with its climate. I think this is a pretty reasonable explanation.
Mm-hmm. Yeah, I like that timing argument from Earth, but also from like a world building perspective, imagining other aliens. There's no reason that intelligence should be a default necessity on a planet. You don't necessarily need to have a huge nervous system and cerebellum to survive on a world. So I think this has real staying power for me.
It is kind of fascinating that evolution went down this pathway and has carried this concept as far as it could. But it really is, the planet belongs to the bacteria, to the microscopic organisms, that they're the true life forms. What is it? We're more bacteria than we are people.
Right. Yeah, like our fact. Individual bodies.
I'm a spacesuit.
It drives me crazy.
For bacteria. My only sort of problem with this is I think that given enough time and enough chances, that even fairly simple life will get up some really interesting emergent behaviors at various scales. Look at ants making ant nests, termites making termite mounds. It could very well be that there isn't anything special about being multicellular. It's just that's how evolution figured it out here on Earth. And I wouldn't be surprised if we find another civilization and they're just the sum of bacteria, and yet seem intelligent.
That emergence argument is super interesting. You ever seen the slime mold, that fungus, the slime mold that finds like the most efficient route from where it is to the nutrients? It's like more efficient than civil engineers building cities.
Yeah.
And that's this like idea of emergence, how over large scales, these things can kind of like compound in ways that we don't really understand. Honestly, I feel like that's what consciousness is. It's just emergence of whatever's happening in our brains. And yeah, like intelligence could be something completely different than we're thinking of. And it could arise from something as simple as fungus or mold or bacteria. So that's really interesting too. I haven't really thought about that.
Mm-hmm. All right. Well, now you're going to have to boil down your thoughts into a number, a letter.
Yeah. I'm going to go ahead and give this one a B. I think this is a solid middle of the road answer.
Yep. Moya?
Yeah, I like a B. I do love picturing those aliens, dumb aliens just chilling on their planet, peaceful. But yeah, a B sounds nice.
Yeah, I agree. I think that timeline to go from single cellular, as you said, 3 billion years to, like, if that just shifted a few 100 million years in either way, that would change everything. And so it's kind of surprising that it finally figured a way out of single cellular life. So it feels like we almost lucked out on Earth. All right. We're alone. And the reason we don't see anybody out there is because there is nobody.
I have a clarifying question. Is this that there is nobody right now, or that there is nobody and there never has been anybody?
There is nobody. There's never been. Life has only formed on one planet in the entire observable universe.
See, I'd give it to you if it was just we're missing each other timing wise, but well,
that's coming later. We'll get there.
Okay, cool.
Yeah.
I don't think this is very likely that out of the 14 billion plus years in the universe and all of the planets, that we would be the only one with life.
Yeah, this it doesn't it doesn't work out in any way for me. If the universe is infinite, who knows if it is or not, then the fraction of planets that have life is 1 over infinity. It doesn't if it's happening once, it has to have happened.
It's only the observable universe, so it's only 1 over 2 trillion galaxies times 100 billion stars.
Okay, so at least it's not over infinity, but still no.
Right. Yeah.
Still no.
Yeah. So the problem with this, and in fact, your advisor, Dr. David Kipping, made a really fantastic argument about this. That is that just the numbers on the small end of things happening, we have no way to know if it's 1 over 1 to the 100 or it's 1 out of 2. We just don't know. Mm-hmm. And so us being alone is the perfect argument, in that if it was true, it would completely explain what we see. It would line up exactly, even better than the we're first. It would line up exactly with what we see in the universe. And it would be the same for all civilizations because it's only us. So, and at the same time, our gut says, but the chances, and it's that unfortunately, we just don't know. We only have a sample size of 1. And I don't think personally, I don't think the gut is a good way to judge your sample size, to judge your statistical possibility of this happening. And yet I get the instinct. Mm-hmm. And as I said, David Kipping's presentation on this is just great, because he just goes like, your gut is not ready to make these kinds of statistical judgments. So
yeah, but we're not just using our gut. I know David. I know how much he loves Bayesian statistics. He loves a good prior. And we have studied enough exoplanets by now to have some priors on what those planets are made out of and what resources they have available. We know the building blocks for life are common. So now we just have to figure out how common is that initializing process. And that's not just gut. That's actual statistics going into it. And
if anything, we're getting pretty close to setting up those conditions in the lab here on Earth.
Yeah, exactly.
Yep, I agree. Mm-hmm. All right.
Frankenstein does not like this. Does not like this hypothesis.
Give me a number.
I'm giving it a C.
Okay.
I'll give it a C. I'll give it a C as well.
All right. I would give it an S. But I'm gonna cede the ground to you guys. Yeah, I think it's
seed.
I'm going to CEDE. I'm gonna give it to you as my resident experts. But I find that we're alone to be like it answers everything. I hate it, but it answers everything.
It would be a good answer.
Okay,
if it were
so
true.
a little pushback. What, say there's a civilization that's exactly where we are in the Andromeda galaxy. What would they see with our technology looking at us? They would see that they were alone. And I feel like you could actually use this argument for probably anywhere in our galaxy that's not directly, really nearby, but anywhere in any galaxy. So that seems like a sort of a flimsy pillar to stand.
An example is that the theory goes that some advanced civilization will have made an impact on its galaxy or its star in a way that is noticeable, that in the future they're going to build Dyson spheres, they're going to rearrange the stars in their galaxy, they're going to turn their galaxy into something that is more useful for their needs as a civilization, in the way that humanity turns the resources of planet Earth into something that is more useful from our perception of our utility. And so you see rainforests burn down, you see cities, you see shipping lanes filled with boats, you see all of that stuff. And so in theory, a hyper advanced civilization that is able to work at a cosmic scale would actually be starting to manipulate their galaxy in a way that was observable from afar, is the thinking. And so what we see is wilderness. We look out into the universe and we don't see that. We see galaxies, stupid, disorganized, randomly rotating, filled with stars of varying sizes, dangerous ones that explode as supernovae. That is not what an advanced civilization would want to do. They would want to sort that out.
Right. So then okay. So this is, we're alone in the sense that there aren't hyper advanced technological civilizations, but not that we're alone. Right.
That we can't perceive because, that if there was an advanced civilization that was causing some kind of impact on their environment, we would see it. That a billion years of technological development, people can get up to some shenanigans.
No, yeah, I got you. But if there are other humans at our level in other places, that doesn't count.
Right, exactly. That's back to we're first. They're effectively at the same technological level, and we're going to meet up with them and give them the Vulcan sign shortly. So, and that's why for me, like, I feel like we look out, we see a wilderness. We don't see civilizations at the largest scales, and yet they've had a billion years to get to this. So that's, for me, it's S tier. But again, I want to give the ground to my guests here. I'm going to be a gracious host. So communication barriers. So aliens do exist, but they are not communicating at a level that we can have. Of course, they're not sending out radio signals. They're using gravitational waves and neutrino beams to talk to one another. Why bother using they wouldn't bother to use this stupid technology that we do. So Moya, what do you think?
Yes, I'm very into this. I complain often that as a species, humans are too sight-oriented. I think we factor vision and the electromagnetic spectrum into too many of our hypotheses and thinkings about outer space. So, if there's a species that didn't evolve to see, why would electromagnetic radiation be the first thing they start to communicate with? So I'm big into this.
Yeah, that makes sense. That's a good way to think about it. But yeah, this like language barrier, especially when we start talking about technology. I mean, you go back a couple hundred years and you couldn't speak with a radio to somebody else on Earth. So I definitely think that there's this possibility for a communication barrier where they're doing something better or more effective or something that like lasts longer in space. I do think that electromagnetic radiation is a good way to go, even if you didn't evolve to see it, because you would come across it in physics, presumably, maybe not, but it does seem like that would be something that you would utilize.
You could be aware of it though without making it your primary thing. Like there are so many examples of this in the history of science on Earth of people in the desert not using wheels because they had camels and other pack animals that could do the job just as well. Like it's really based on your context and your environment, how you will adapt your technology.
Yeah, I think. If, we agree that we live in a universe with energy and matter, then alien civilizations will have those same constraints as us. They're going to have electromagnetic radiation. They have to know what it is. And they're going to be using the raw materials that they find on their planet to begin their process. And that even if they've technologically moved to neutrinos because obviously it's the best way, they may still downgrade to attempt to communicate with other civilizations. If they're powerful enough, then it's no big deal to leave a transponder going in radio waves just to help some future other civilization learn that they're there. So it seems almost rude to not.
That's like if they could even identify that that's what we're using to communicate. Like they might see a bunch of light waves coming off of us and be like, "Oh, what party are they throwing?" I think it's not immediately obvious that it would be a form of communication.
But would 100% do that? Look, it's fine if half of them do it, but what about the other half that we can see?
It also seems, starlight seems like such a useful thing to be able to see on any planet. Given, without giving any like super weird niche circumstances. So
you mean like the millions of rogue planets in our galaxy alone that don't orbit stars so they wouldn't have access to light? Like, yeah.
You think that those are like viable homes for life?
I think they can be, yeah. If they have internal volcanism and other processes, they can hold on to an atmosphere.
Apparently, even these Haitian worlds now, it's theorized that they can hold on to an atmosphere. Like, they can have liquid water on their surface with a thick hydrogen atmosphere that those are surprisingly habitable, even in really extreme environments.
Rogue planets, surprisingly habitable.
Yeah, you put Jupiter, you put it out in the middle of the interstellar space, and now you've got volcanism on Ganymede and Io, and you've got the conditions for life deep under the ocean on rogue Europa.
Mm-hmm.
Oh, I'm not sure how I feel about that.
We just sent Dakota spinning. He's going to have to really think about this.
You know
later.
Europa, right?
I know Europa.
Liquid water.
Liquid water.
You take Jupiter, kick it out of the solar system. Does Europa still Europa?
I don't know. When you get out of the solar system, you're losing like tons of protection, first of all, right? From the heliosphere, from the sun itself. You're losing like a lot of stability. I mean, I don't know. To me, it seems like a very inhospitable place. You're now being bombarded constantly with cosmic radiation that you really don't have to deal with in any major way.
I think Jupiter's magnetic field can shield you.
I mean, because when you talk about Jupiter and what it's doing to the outgassing from Io, it has like radiation belts that I don't even think we could go visit Europa if we wanted to. Like, we can't.
Yeah, but you go a meter under the ice and you're safe.
And there's an intelligent species in there underwater. I mean, I don't believe that you can have a technologically advanced species underwater on Earth. Like dolphins, without the use of electricity, without the ability to build fires, without like opposable thumbs, you could put Einstein's brain inside a dolphin. And I don't think that a civilization occurs in the way that we're talking about in this like advanced technological, because you're like limited by your environment. You know, you can't figure out, Benjamin Franklin can't fly a key in a thunderstorm or whatever.
Instead you come across an electric eel on your way to lunch. Like, there are other ways to discover
chemical
these things.
Energy.
Yeah.
So these underwater civilizations are now run by farming electric eels and like industrial farms where they're zapping them. Maybe.
You got to work with
how many electric eels to fuel Earth civilization?
Well, they're not Earth civilization is the thing. It's Europa's civilization. They would figure it out.
Yeah.
Okay.
And then once you get to space, then all bets are off. I love thinking about, what if you were on a rogue planet orbiting through the cosmos and all you had to work with was chemical energy? Could you bootstrap a civilization, an advanced civilization, purely from chemical energy? But you've got billions of years of time to process. I mean, you can imagine a pathway forward, and yet so much of life is life figuring out crazy pathways forward. So fire makes it easy. We get easy mode, but you can imagine a civilization that gets hard mode. Maybe they've got twice the surface gravity, and then and rocketry looks completely different from their perspective, or that they're on a water world and there's no access to nutrients from the bottom of the ocean, and they can only retrieve nutrients from cosmic dust that is falling on the ocean. There's a lot of really interesting ideas, and yet it's never nothing. So it's always something to work with if you're creative enough.
Mm-hmm. I'll send you some Waterworld episodes of Exolore I've done, Dakota.
I'll send you some papers on Rogue Planet habitability.
Please. Send me all this. Send me all this goodness.
That sounds great. All right. So then Dakota, why don't you give us your grade?
I'm gonna have to say a C.
Okay. What?
I was about to give it an A. Oh.
Well, then I will balance it out to a B, because I forgot what the category was.
Judging
habitability of rogue planets.
Y'all made me so upset about saying that rogue planets had life. I forgot what we were saying. You know what? I'll give it I'm comfortable with a B or an A. You know, I feel like it's unlikely that we're gonna.
All right.
Yeah.
Well, let's go up one. Sure. I am a kind and benevolent moderator. Okay. Post biological life. So advanced civilizations do exist, but not in a way that we comprehend, that this physical manifestation as we live in these meat bodies in the universe as we understand it is just a phase, man. And you transcend to a higher level that really has no way of detecting from our current meat space. And yet they do share this universe with us. They have just non-overlapping.
I'm a big fan of Stargate. I hated when Daniel left the show, but I love that he ascended to that higher plane of being. So I love this idea, but I don't think that it would happen to everyone. And if they, one of the examples that you gave in the text was that maybe they become roboticized or they become AI or something, and that still requires energy. Like they would still produce some sort of no, they don't.
Yeah, we'd still. Yeah, I mean, the point is we would still see them. So that
so
doesn't count.
Okay,
right? Like they have to be that we have no way to perceive them.
Okay, yeah,
I just think that's quickly pass through this phase and move on to the next phase, and then they are inaccessible to our feeble comprehension.
They would have to be like incorporeal, ethereal beings that don't require any fuel or interaction with anything. And the idea that every single species in the universe gets to that point, it'd be nice.
It's the natural, it's the obvious choice. Oh. So in the Culture series, I don't know if you guys have read Ian and Banks, there is this idea that they grow the AIs. The AI is born, they grow them, they interact with them, and then the AI chooses their name, and then they get to decide what they want to be. But every now and then they just make them, and every time they do, they instantaneously ascend to the next dimension, that they don't want to stick around in the universe at all, that it is the natural outcome. And so in the Culture series, entire civilizations are aware of this higher plane of existence, and nobody ever comes back from it. And they, as an entire civilization, have to decide if they want to move on to this next phase. And a lot of the stories in the Culture series are about civilizations wrestling with, do we want to shed this mortal coil and become that next phase? It's a great concept. I like it, and it would nicely explain it. So, Dakota?
Yeah, I mean, when you talk about another layer of consciousness, I don't have it because I'm a human. Unfortunately, I haven't reached that yet. But it's like, what do they care about then? What do they want to do? Would they want to even do something that left a huge mark? Would they value, thriving in a way that minimized the mark that they left? Would they ever, would they care about traveling to other stars or even other planets? I don't know. I mean, probably not. This all seems kind of like stuff that's driven from some instinct that we have from the past. So, I mean, I could see this. I mean, right now we have AI. Obviously, it's not anywhere near where we are as humans, but in 100 years, who knows? So, I think that this is reasonable. Or like, if we can get to the point where we can like upload our consciousness into some sort of cloud or something, into the metaverse. I won't be doing that.
But you're still going to need a physical imprint. I think that's what Moya was getting at the beginning, which is that you're going to need still some physical tether. You're absorbing the power coming from the star. You're crunching up asteroids to build your servers.
Dramatic? I don't think it has to be that dramatic. Like, you could like be siphoning off the energy from a star in a way that's detectable, but I don't think it has to be that dramatic. I think there's a lot of energy here on Earth that we don't use: geothermal energy, wind energy, solar energy, and I think that we could be like so efficient without, waving flags to onlookers that we're here, using all the energy around.
So if I'm understanding correctly, in this scenario, the natural consequence for all species in the universe is that they get advanced enough artificial intelligence so they can all upload their minds, their consciousnesses to the cloud, and they're using the most efficient type of geothermal energy possible so that they don't re-emit any heat that we can detect?
Well, when you put it like that, but no.
Well, but they shift to neutrinos.
Okay. Okay.
Right? That neutrinos are actually a much better substrate to run your civilization on, and you no longer need regular old electromagnetic energy or matter. Now you're living in the neutrino subspace. And and neutrinos are already hard enough to detect, how could we find them?
Okay. I just heard you say they become neutrino people. That's how I'm thinking of it in my head.
They become neutrino people, yeah.
And they exist on another plane.
That we cannot detect.
On a different dimension. Okay, yeah.
That wasn't my answer.
And then it was your answer, and this is sort of one of the ones that we cover later on. Mm. So I want you to wrestle with this one first, because we'll get to the one you're talking about, Dakota. And I see this in the YouTube comments all the time. People say, like, well, of course you don't see the aliens. The aliens are so advanced that they transcend. And it sounds very spiritual, I think, is why it feels very intriguing. So it is just like, as we are to the spirit world, the future, but instead it's technology.
Yeah, this is when tech bros go Buddhist.
Yeah. Yeah.
Okay.
Yeah.
I think it just clicked for me the points that you were both making when you said it like that. I got you. It's like this. Yeah. Okay. I got you. It's very wooey.
Well, and I think you would still, why not also use electromagnetic radiation? Why not also use matter? Like, use your neutrinos, but also use the other stuff too. And then that's the heat that's detectable, which is what Moya's getting at. So, but now judge it, Moya.
I'm giving it a C. I would have given it a D, but I really like when Daniel becomes that floating ball of light.
Yeah, or her, where his girlfriend decides she doesn't want anything to do with humanity anymore and join the rest of the AI in the Great Awakening. Yeah. It was a she'd outgrown him. I loved it. Dakota?
So I'm going to give it a B, with the caveat that there's no like transcendence into another plane or dimension or something like that. But I'll give it a B. But
it's Arthur C. Clarkean. Any sufficiently advanced technology is indistinguishable from magic. So they do it. It looks like it's spiritual and magical, but it's physical.
Okay, then I'll give it a B.
B it is. All right. I'm gonna split the difference here, and I think I'll go with the B as well. It would.
Oh, look at this nice distribution we're getting.
Yeah, this is good. All right. The hibernation hypothesis. So advanced civilizations do exist, but they are in a state of hibernation, and that is because the future of the universe, when things are very cold, are actually a lot better for civilizations to operate. That when your temperatures get cold, you can run your supercomputers, you can run your quantum computers, you can run them backwards. That they've realized that what's best is to wait for the universe to cool down, to be closer to the heat death, but actually then you can just run out your clock cycles and everything is vastly more efficient. And so it's just, they realize that now is not the time to be present in the universe. The future is a better time. And so they all go to sleep. And I think a version of that for us, like if you guys could hop in a future time machine, would you do it? I think I would. No, I would.
No, I'm way too pessimistic for this conversation right now. I think I feel like if I chose any random point in the future, I'm worried it would be worse right now.
But then what about like a million years from now? Hopefully they would have figured it out.
If we're still around.
What if you could go into a time machine, a future time machine, but you could perceive the state of humanity and then you could stop the journey at any time?
Yes, I would do that.
Okay. Well, then there you go.
That's interesting.
That's what this is. This is them saying that the current state, and maybe there's something we don't understand, that there's something about the universe that is better in the future, and everyone immediately realizes it when they reach a certain level of technology, and then they go to sleep because why bother right now? The future is going to be better. Dakota?
Yeah, I with the way that you described about being aware and being able to stop and get out when you want, that okay, maybe like that's appealing. But if you're like going so far that you're getting to the heat death of the universe, we're talking about hundreds of trillions of years or trillions at least. That's like, I'm more optimistic than Moya, but not optimistic out until like 100 trillion years. I'm not that optimistic. So I don't, that seems like far-fetched. Like, how are you sustaining yourself for trillions of years or even billions of years? You know, that seems like a technological feat, like a major hurdle. But, you know, like waiting to go to the future, I don't know. That's not, it doesn't really feel, it doesn't seem right.
I think that a lot of civilizations might prioritize the present more.
Yeah, it would explain it. I guess is the point, is that it does explain the Fermi paradox, but it doesn't explain it very compellingly, because why wouldn't you also use this time now and then also use the future time?
Yeah. If you're smart enough to predict that it's coming and figure out how to freeze your society in the meantime, then you should also be smart enough to make the most of what you have now.
I'm sort of like picturing a society that froze everybody, but they accidentally froze the last person and forgot to leave somebody unthawed to unfreeze everybody, and so like now they're just frozen forever.
It's probably a science fiction story. Yeah, yeah. All right, Dakota, let's give it a judgment.
I'm gonna have to put this one at D for me. This is one of the weaker.
Okay. Moya?
Yeah, I'm inclined to agree.
Yeah, I agree. I think there's no reason why a civilization wouldn't, if there's some perfect situation, then they can create that now and live in that, and also use that additional energy and matter to make more of that. That the future only gives you less. Our technology isn't good enough. So this is the classic, we've only just started to explore the universe. We've got rudimentary space telescopes, rudimentary radio astronomy. And the analogy that people always use is you wouldn't go and put a teacup into the Pacific Ocean and then wonder why you don't see any whales. We do not have the technology to be able to conduct a thorough search for the aliens out there. Moya?
Yes, I think that this is just a fact, actually. I mean, we didn't find planets until the 90s. We didn't have gravitational waves until the last decade, the teens. I'm very convinced by this argument that we eventually will have technology good enough, but right now we're still fairly early on as a technological species.
Yeah, I think that's definitely right. We're very early on. We're still debating whether or not you could even have life on a rogue exoplanet. So we're in like the baby stages here. And I think that the one thing that it seems like gets caught up maybe in this answer, or perhaps it's something a little bit different, is when people want to invoke that aliens, and I guess this is more so for like civilizations that have been here, that have like been on Earth or something, that they have some like physics bending technology that like breaks the laws of physics as we know it or something. And I'm always super skeptical for that sort of answer. But you know, if it's just explicitly that we are technologically aren't really there to do a proper sweep of the galaxy, you know, that might be something that's always true.
I think that analogy of the looking in the ocean falls apart, because if you take that teacup, you take it back to the lab and you look in it, you're going to find all kinds of stuff.
Find whale DNA in it, probably.
You're going to find whale DNA.
If you have the lab equipment. And maybe we just don't have the lab equipment, Fraser. Maybe we have dipped the cup in and we just don't have a scanning electron microscope.
And I think, though, we also go back to this idea that a big enough civilization should make a big enough impact on the universe that the complexity of the lab equipment that we need goes down. That we look with our eyes and we look with our telescopes and we see rearranged galaxies. So I think, in theory, how far, I don't know, like ants detect us. And they don't have great technology. They know they bite us. They don't understand us, but they bite us. They eat our houses. So I think, we don't have to be at the same level of technology as the advanced civilizations to be able to detect them. And so I think...
But the scale is so different.
Yeah.
The ratio of like our difference in sizes between ant and human and like the distance between us, I think it's totally off from the distance between us and any potential aliens.
But I guess the point being that an advanced enough civilization will have spread comprehensively through the universe that you don't have to go very far to look for them. They should be everywhere.
I will never, ever be convinced by that argument. It is too imperialist for me.
We're going to get to that shortly.
Believe.
So
yeah.
Yeah. All right. Then give me a judgment, Dakota.
Yeah, I would say that this is okay. We don't have the technology. I think B for me. It's like, yeah, we don't.
I want to give it an S.
Yeah?
Yeah, I do.
All right. Well, I want to split the difference with you then. And I'm going to put it into an A. Because I feel like they would be, and we will definitely have this argument shortly, but I feel like they would, if they were successful, they would make themselves more obvious. So it wouldn't require advanced technology. We're searching in the wrong places. So aliens are everywhere. We think we should be looking at them around, listening to various stars, looking for planets orbiting other stars. But in fact, that's ridiculous. Everyone immediately moves out to the cosmic equivalent of the suburbs. And so we should be looking for the rogue planets, not the terrestrial planets orbiting around sun-like stars.
Our search has been fairly extensive, like as extensive as it could be. We've done big sky surveys. We've looked in at different types of stars. We've looked in some different parts of the galaxy. So we have this idea that space should be kind of isotropic, that the things we find here in this galaxy or in this neighborhood should be similar to what we find in any other neighborhood. And we've looked at enough places. So I don't think that that's the problem.
Yeah, I don't think it's that we're looking in the wrong places. We did, just to expand a little bit on what Moya was saying, we kind of like stared into the galactic disk towards the center where we saw like a really deep field with Kepler. We've done these more local searches that are sort of more comprehensive around the sky with surveys like TESS. We've looked quite a bit. Now it's possible that we haven't looked in enough places, but I wouldn't say that it was that we were looking in the wrong places altogether. Like we're just missing something. And
it would have to be 100% wrong. Like we would have to, that it's ridiculous to think that other civilizations are going to be living at planets around other stars, that stars are the places to look.
And right, on the surface, in the corona.
Well, no, but like the planets, like if you're going to have some advanced civilization that's sending out a transmission from, and they're in orbit around a star, you point your radio telescope at the star as the beacon, but in fact, you're trying to pick up the signal from the civilization that's living on the planet. That in fact, the universe is buzzing with radio transmissions from civilizations. They're just never coming from the star. They're always coming from the gaps in between the stars.
But it's not like our radio sensing is that fine-tuned. We're not tuning it in on an individual star and ignoring the system around it. We would also detect those signals from the gaps between stars.
Yep.
Yeah.
So,
cool.
Moya, do you have a judgment on this one?
I'm giving this a D. I can't think of a place that we have just like completely neglected to search that we could search.
Yeah. Dakota?
Yeah, I'm going to go with D too. We're not looking in the wrong places.
We look everywhere.
I mean, people have looked on planets. We've looked on moons. People know about rogue planets. People are we have been agnostic enough in our search in terms of location that I don't think this is our problem.
100% agree with you. Yep. Yeah, I think if there's scientists are willing to throw every idea against the wall and try them all because you never know. All right, aliens are among us. So the aliens, not only are the aliens present, they are here. And this is like a version of, I guess, of the zoo hypothesis or the prime directive, but they are just right here on planet Earth. And, some people already know about their existence, and they are just keeping this quiet from the rest of us. So I guess the truth about the Fermi Paradox has already been figured out. It just hasn't been equally distributed yet. There are those who know and those who don't know. Moya?
You heard both of us laughing earlier. I think that this is an extraordinary claim and it would require extraordinary evidence, and I have not seen any such evidence. Any sort of cloaking technology, okay, maybe, sure, if they're like up in our atmosphere, but if they've come down to the surface, if we're interacting with them, that is where it breaks down for me. It also breaks down in the idea that individual people who do know would actually be able to keep it a secret. Have you met a human? Have you met an astronomer? We are such gossip girlies.
They don't shut up.
No. So I have a hard time believing in this.
Yeah, same thing. It's for me, it's all about the evidence. Like, is it possible? Sure. Sure, it's possible. But there's nothing that I see that's put forth as evidence is convincing in any way. And then I think for the most part, a lot of times when people who study space are almost always the people who don't believe that the aliens are here. And for me, I think it always just has to do with sort of this distance problem. There is no conceivable way to travel these great distances that we know of. And when you combine that, the fact that it would take 40,000 years to get to the closest star, with the fact that we're not seeing any evidence. I mean, we have evidence for all different types of things. We have evidence for how old the universe is. We have evidence for how many years ago the first life on Earth was around. It's just, and there's no evidence at all that's convincing, that like holds up in a court of scientific law. I can't get on board without seeing more.
I'm going to put this in the D category unless somebody wants to veto that.
Go for it, Fraser.
All right. 100% agree with you guys. I have no comments in the above and beyond what you said. So Interstellar is impossible. And so back when you think about Fermi's original proposal, he sort of did this back of the envelope calculation and said, well, the universe is big, the universe is old. And then let me just do some quick numbers here. It would take a couple of million years for an advanced civilization to explore the entire Milky Way galaxy. You go to a star system, you make copies of yourself, you go to other star systems. It doesn't take you long till you've reached every node in every star in the entire galaxy. But that requires the ability to move from star to star. Maybe there is something fundamentally just impossible about going from star to star, that we'll never be able to get to the speed of light. We're never going to build warp drives, but maybe even we're never going to be able to go faster than 1% the speed of light, or 1,000th the speed of light. And so it's just not feasible to try to go out to any other star.
Yeah, that's kind of how I think about it. Is it really impossible? If you could, you hear ideas about something for a warp drive where if you had enough energy, maybe you could like play with space using gravity and kind of cheat your way going to traveling faster, or maybe if you could contain a wormhole. But these are things that require amounts of energy that are really inconceivable to us as humans, or in my opinion, any sort of animal species. So I would say that this is probably the big separator between species on different planets, and I would rank this one pretty highly. This makes a lot of sense.
Yeah, I agree. We don't have a good physically realistic way to get that fast. So I think it would be really hard for other civilizations to do on a mass scale.
But now you're going to have to wrestle with the other side of this, which is that what you're saying is that we will never go to another star.
I'm okay with that.
You're okay with if some child comes up to you, holds your hand, looks into your eyes, tells you that they want to be a
Moya.
Yeah, boy, I want to be an aerospace engineer, and I want to build the first probe that goes to Alpha Centauri.
Tough
And
luck,
you look
kid.
down, tough luck, kid.
Tough luck, kid.
Pick a different job. Have you considered?
Or just pick a smarter goal. You know, pick a more achievable goal.
You are overreaching. You will fail.
Dream smaller.
Get her out of here. Yeah, dream smaller.
Yes. No. It's not that I think it's. I think it's really hard, and I just don't think we need to.
Really hard and impossible are two different things. You're going to need to give that. You're going to cut that line right there, because if it's really hard, then if 10,000 civilizations go for it, and only one is able to pull it off, you still get the entire galaxy explored.
Can I tell you my little conspiracy theory? My little hypothesis? I think it would be easier for civilizations to figure out how to digitally transport copies, like digital copies of themselves across great distances, than to physically transport themselves through faster than light travel.
Great. Now you're arguing against yourself. Keep it up.
Okay, fine. Well, if that's the case, then sure. Yeah, if it's like a teleporter machine across great distances, yes. But I don't think moving is possible.
Doesn't matter. However you make the journey. The point is that if interstellar travel is possible, then you should end up with a civilization being capable of exploring every place in the entire. We should see their giant robotic von Neumann probe factories here in the solar system when they reached us.
I like the idea that their digital projections can't actually influence space around them. They just observe. They're just scientists going to different places digitally. Like big Zoom meetings across the universe.
Yeah. Dakota?
I think that this is a really good one. When if you're gonna make that distinction and like force a stance on impossible versus not impossible or versus possible, then I still feel inclined to say that it's impossible. But I'm open, as a scientist. I feel uncomfortable saying that, but I'm definitely open as a scientist, because if there is some way, I would be totally open to that. But right now, I do feel comfortable saying that it might be impossible. It probably is impossible. Like 52% chance that it's impossible.
So what do you think about Oumuamua? It's a rock that made the journey from another star system. And then Borisov did it.
True, it did. And it was... Oh, sorry, go ahead.
I was going to say, if a rock can make the journey, if a dumb rock can make the journey, do you think why can't a smart rock?
Given enough time.
Yeah, so right? Where did Oumuamua originate? Was it 5 billion years ago somewhere? Am I going to say that? Yeah, sure. There could be a spaceship that's been traveling for 5 billion years. I don't feel comfortable. I wouldn't say that. That doesn't sound right. That's not believable to me.
All right, I'm going to blow your minds. So, in about 1 million years, a star called Gliese, I forget, one of the Gliese, 714, whatever, is going to pass within 70,000 astronomical units of the sun. So it's going to get within a light year of the sun. And that if you take that number and you extrapolate, you actually find that stars make vastly closer flybys of the sun. They come within 0.1 light year, 0.2 light year. And that people have done calculations that if you just wait for those close flybys for all the stars that come within striking distance of your star, it only adds a few extra million years to the amount of time it takes to fully explore your galaxy. You just wait for the ferry boats to come by, and then you jump star to star. And then it only expands your exploration time by a few million years.
Just a few million years.
Which is not that long.
In a universe that's been around for billions. If it was going to take you 10 million years to do it before at 10% the speed of light, now it takes you 12 million years.
Right.
By waiting.
But we're talking about a civilization, though. So that time scale does matter. We're not just talking about that the universe has been around for a long time. We're talking about like a coherent civilization that's sort of carrying out this methodical thing. And that timeline seems pretty extreme to me.
But there are places in the galaxy and certainly in the universe where those types of stellar interactions are a lot more common. That was the motivation for one of my grad projects, looking at the bulge, the center of the Milky Way versus the disk. And here the sun is in like several million years, like tens of millions of years, that we expect this kind of close encounter. But you get closer encounters way more often in denser parts of the galaxy.
You do, but those areas are also very different environments for sustainability and like stability for life. So when you're having more and more encounters with stars, you're having probably less stability within the systems. There's more sort of errant radiation coming from other places. So life may be much less likely in those regions as well.
All right. So just to sort of formulate this correctly, Dakota, I'm going to need you to give a letter grade for the Interstellar being impossible as an explanation for the Fermi Paradox.
I'm going to give it an A.
Yeah. Moya?
Okay. I was going to say like B or A.
Remember that little girl?
That little girl.
The little aerospace engineer.
Okay, I'm giving it a B.
And she looks at you, she goes, yeah, but stars are going to come really close. And you go, yeah, I know.
I'm going to say, please leave me alone. I don't know how to talk to you.
A rock made the journey from one star to another. That's got to mean it's possible, right?
Okay, fine. Solid B. A solid B.
All right. I've got to downgrade it to a B. I got to agree with Moya on this one. Yeah. I can't. And I'm not listening. I want my warp drive. I want my Stargate. It's got to be possible. All
yes.
Right. So there's some science fiction video games and books. This idea. Have you guys played the Mass Effect series? You probably are familiar with them.
I did play that. That was a cool trilogy.
Yeah. Probably my favorite video game series. And there is a race of artificial intelligence that, if you haven't played the Mass Effect series, you've had 20 years. So I've got to be able to spoil this.
Yeah.
Anyway, they come through and they reap the intelligent civilizations on a regular basis because letting any civilization go too long, they are too self-destructive, too dangerous to the stability of the galaxy, that they're going to try to take it all. They're going to force their will on everybody. They're going to colonize and oppress. And so instead, you cull them back down to the bare minimum so that nobody ever gets too out of control and at this sort of specific timing. And the Berserkers are sort of a version of that. And this is a science fiction series by Frederick Pohl. And the gist is that an advanced civilization wants to remove any potential threats to the future. And so they send spacecraft to various star systems, look for any budding civilization, and then you reap them so that they aren't a threat to you in the future. So the gist is that some malevolent or, well-intentioned group comes along and reaps intelligent civilizations and sets them back to the beginning again on whatever is the basis required to have the universe appear as we see it today. Moya.
I feel like this brings up something that we've talked about a lot here, which is if they were truly that widespread and capable, then they would leave a signal that we could detect this berserker species. I also feel like maybe the same problems that Rome had when it really tried to extend its reach. I feel like that might apply here, where they would get so far extended that the central power of this berserker species would lose authority.
So Alistair Reynolds has a great series, the Revelation Space series, and in that's what's happened. So essentially the Reapers have come by, but now they're old and they're getting dumb and they're getting senile and they're not able to be as comprehensive as they once were. And this is allowing cracks in the universe that people can try to spread out and try to escape this. Yeah.
Yeah.
All right, Dakota.
Yeah. So this one is I certainly hope it's not true that some advanced species is coming along and doing a galactic haircut every time our bangs get too long. But I think that where I go is the sort of question to like, why would this start? Because presumably this is now the first advanced species. And then they saw other species come up and do things and decided over time that they needed to just wipe everybody out. And so I have like questions about why is that is this the first species ever? Like the first technologically advanced species? And what types of things what could we do to upset the balance in the universe, right? Sure, we could destroy planets. We could use up resources. We could maybe even destroy stars. But what could we possibly do to the universe that sort of overseeing technologically advanced species needs to wipe us out? Seems kind of far-fetched.
And Moy, you think it would be obvious, like if they're doing this, then we would see them.
I think so. Yeah, if they had that mass operation.
Yeah. I agree. I think if this was out there waiting for us, then we would see their civilization as the thing to fear, because they're using the resources for whatever purpose. And so the fact that they're both hiding but also reaping seems really weird. Like, pick a side.
Exactly.
You're either a dark forest or you're a reaper. You can't be nervous about your reaping.
Mm-hmm. Be consistent, please. Yeah.
Yeah. All right. So Moya, can you give us a letter grade?
I'll give it a D. But I'm willing to hear other people's arguments to bump it up.
Yeah, I don't think so. I think D is a good place for it to be.
I love the Mass Effect series. I love the concept. I love reading the science fiction. I don't buy it.
Yeah. I love the Wraith. Again, Stargate. They're great, but
Same. This concept is, and again, I think this is sort of our stories incorporate this. That when you think about a lot of mythology, that we're not ready, we're not prepared to be present in this, whatever is the right way to live. And so we have to constantly have the judgment from the gods to knock us back down to our place. And I don't think that's holds water, because where are the gods, right?
Where are the gods? They're sending their
floods.
If
they're smiting us, we should at least see the smiting. Expansion is inefficient. And so this is an idea that is on more of a technological base, but it's fine to expand it a little further. But the idea is that if you have, say, a technological civilization, the lag is a killer. That the more that you are attempting to have to communicate from node to node, you're affected by the speed of light. And at a certain point, your parts of your civilization are so far away from yourselves that it's essentially another civilization. That if you're going to try and communicate to a civilization that's at Alpha Centauri, there's no direct path to go back and forth. And so they are effectively a completely other civilization. And so civilizations just don't care. And you can sort of expand this, that there's no reason to expand. But I want to get to this, not that there is a physical reason that you don't want to expand, as opposed to a philosophical reason, which I want to get to next. So more on the physical side.
Yeah, I think that's a great argument. It would weaken a civilization to not have as immediate as possible communication between groups, especially once you're used to a certain level of immediacy. Like in our history, we've gone from pigeons to snail mail to like texting. But if you have texting, you don't want to go back to snail mail communicating with your buddy across the galaxy.
And that's really interesting. And that immediately made me think of, because I just watched, I never read the book Three Body Problem, but I have watched the series on Netflix. And they employ this sort of quantum entanglement argument for instant communication, which, like, who knows if that's something that we could actually do. But it does kind of lay a framework for this immediate communication. Maybe it's not possible, but it's like maybe conceivable. But regardless, surely it's super inefficient to be trying to go out. You still have this distance problem. You're eating up a bunch of resources. For sure, physically, from an energy perspective, it's very inefficient.
And if you aren't able to align yourselves sort of philosophically with these other civilizations that you're setting up, you're kind of seeding the universe with your competitors, because you're no longer in instant communication. You're no longer one shared hive mind. There's you and there's them, and their very existence is your fault. You're like, wouldn't it be great if we set up another Computronium world at Alpha Centauri, but now you're no longer aligned with them. They move in a different direction, and then they send the Reapers back to you, and you have no one to blame but yourself.
Because there are really only a few reasons to expand, and all of them lead to kind of a snowball effect of getting radically different views. You would expand because of conflict, because of necessity, like you don't have resources around you, or because you are curious and you want to explore. And for all of those three things, like whatever your initial motivation is, you're going to get driven more and more towards that, and the societies will diverge more and more. And I think social groups anyway, would recognize that that's not a benefit for them.
And I think that exploration is a very sort of low footprint in terms of your moving about the cosmos. So you can imagine an advanced civilization. They've got their Computronium world, and they've sent out their explorers to at least understand the lay of the rest of the galaxy in case there are some potential threats that you want to know about. But apart from that, you never want to leave the hive, because everything else is inefficient. And if you do, then you're just going to potentially make competitors to yourself.
Yeah. That's that's what you see here. When you split up a population, they're not communicating as much. They turn into new species eventually, and sometimes very, very different. So why wouldn't that also be true as you go out and expand throughout the universe?
Yep. Okay, so let's give it a letter grade.
Very for it being inefficient, for expansion being
for it being the explanation that any advanced civilization realizes that there's just no efficiencies to be made moving beyond their home star. No reason they just stay home.
Yeah, I'm gonna go ahead and give this an A.
What?
I would like to give it an S. I think I can see it being something that every or most, like almost all individual societies come to. Yeah.
So there's a great series of books, or a great book by a guy named Charles Strauss called Accelerando. I don't know if you guys have read this book, but he covers that. And that's the gist, is that an advanced civilization, if it goes down a certain level, realizes that the lag is just not worth it. And instead stays home. And I really love it. So I'm going to agree with you. I'm going to put it up in the S tier.
I think this is similar to the off-ramp society that I was thinking of earlier, where they realize that if they keep going, they will use all of their resources and run out of power. And so they decide not to exponentially expand.
All right. This is the last one. And so I've just called this There's a Better Way. And it's very similar to what we just had. And the gist is that there is a way to live in the universe that is the most optimized way. You can imagine it sort of a cosmic version of sustainability, that you can remain in balance with the resources that are available to you from the star, from the planet, from the cosmos itself. But it is also the most effective when you sort of reach your greatest level of enlightenment, that you can see what the far future is. You settle into this, and it also happens to be not detectable by us. So we don't see it, and yet every civilization arrives at this obvious final destination.
This is the pan-utopia scenario.
Well, it could be horrible, right? It could also be awful. But the point is that it's just that it is what is sustainable, long-lasting. It is the most balanced way to live in the universe. That if you go the mega expansionist route, then you, like Rome, you must crumble from within. But instead, there's a way to live forever, and all civilizations work this out. So, Moya, what do you think?
Seems like a level of
Dakota.
convergence that would be remarkable for so many different species that are evolving, on completely different timelines and environments. So it seems unlikely that everybody's converging on that. That'd be hard for me to believe.
Mm-hmm.
Well,
I think exactly what I was going to say.
And so then it would be that there's something fundamental to the constraints of the universe that encourage this.
Yeah, some like obvious answer that when you get good enough, you figure it out.
Right. And from our perspective, what it gives you is we don't see them.
Huh. I just have a hard time imagining what it could be. I think for most of these other scenarios, I can imagine something that would make that the case. But what would this like perfect ideal equilibrium state be that matches every single species in the universe?
We don't know, but they all find it. It's the reverse of the Great Filter, right? It's the exact opposite. The Great Filter is some horrible fate befalls 100% of civilizations. This says some benevolent fate befalls 100% of civilizations.
Nah, I don't buy it. Sorry.
You could see a scenario where there's like this better way at the end of the Great Filter. Like if you get through enough of these things, you're eventually going to come to this realization. Mm-hmm. But it just seems like so kind of it's just way too converging for me that it's this one thing that everybody comes to.
So the little girl has returned. She holds your hand, looks into your eyes, and she says, I'd like to figure out a way that humanity can just live in stability forever.
Huh.
Can I work on this? Is it possible?
I would not say tough luck kid to her. I would be like, that's a great goal. And I would recommend looking into really efficient renewable energies.
It's funny to me that you guys are not as sanguine on this as I am, because I feel like this is what humanity has been attempting to move towards. I mean, utopian is sort of one way to describe it, but essentially that we are attempting to optimize over the long term towards some future that must be sustainable, or otherwise we get the other S tier self-destruction outcome. So I feel like it has to be the other side of it, that either we self-destruct or we end up in a level of peace and stability, that we can't live in instability forever, because then self-destruction is always on the table. Self-destruction has to be off the table. And the only way that happens is if we reach stability. That's my perspective. So I feel like they are the two sides of the coin. You get one or you get the other. And I would prefer the stability over self-destruction.
I too would prefer that, but I just feel like self-destruction is always on the table. It just seems like it's always an option.
Right.
Because there are so many ways to self-destruct, but so few ways to reach that perfect equilibrium.
And there, absolutely. Yeah. Yeah. And the analogy is always you've heard you have a big jar filled with marbles, and they're mostly, say most of them are green. No, most of them are green, and then one of them is red. And so you're digging through pull the green. We didn't have a nuclear war. Pull another one. Oh, we weren't killed by artificial intelligence. You pull the red. Wah, bioterrorism.
Yeah.
We're done.
And
we're constantly putting our hands in and we're pulling out the marble. And eventually we'll pull out the one that wipes us out.
I think there are some civilizations that find a better way, Fraser, but I don't think it's all, or even most.
Sure. Yeah. But as long as, so again, it's the reverse. So as long as it's possible, then it will happen an infinite number of times in an infinite universe.
But not when self-destruction is also possible.
Sure. Yeah.
I'm very confused right now. Oh, no.
So this is once you flip this switch, you can never mess up. You've basically like,
you can never mess
you're
up.
locked in forever. It's like passing an exam. Okay. Like what would that be where you cannot mess up? Like you cannot mess this up.
But
I think that's them going to the next plane of existence. I think that's post-biology.
Sure, maybe.
Yeah, it sounds like one of the other things we talked about.
But isn't that what we're trying to go towards?
Some people.
Sure. All right. We are. But
we 3 years.
Awesome. All right. So then give me your grade. I made my best case I could.
It's I mean it's really out there. I'm still not like sold on that being a real thing. It sounds kind of fantastical for me. So I'm gonna go B. Actually, I'm gonna go C.
Okay.
All right. I think I'm feeling a B.
Okay. I'm gonna, because I propose it, I'm gonna come with a B as well. I agree. It's vastly less plausible than self-destruction as an explanation for the Fermi Paradox.
But it is nice.
Also that you just wouldn't see the ones that were successful. So they might be out there, but they're not the obvious ones. The ones that you would see are the ones that are going for their whole galaxy. Mm. And so they're just not relevant to the larger conversation unless they figured out something that keeps them safe, which is a great trope in science fiction. They seem like some pre-industrial civilization, but in fact, they've got incredibly powerful technology that's able to prevent the Klingons from destroying their planet or whatever.
Like the Nox, they can turn invisible. Yeah.
Exactly. In Stargate.
Uh-huh. I only watch Stargate. That's the only sci-fi that I know.
People always ask me, like, if you could, which science fiction future would you like? Which form of interstellar transport would you like? I'm like, Stargate. I put on my hiking shoes.
Yes.
And I appear on another world. Yes, please.
And that other world looks exactly like the Pacific Northwest that you live in.
Exactly. Just feels like home. Remember where I go. All right. Well, guys, that was super fun. Thank you so much for helping me finally rank all of the responses to the Fermi Paradox. I think at this point, as I said, we've solved it. And now no one needs to write papers anymore unless they want to reference this. It's really settled science, and people can focus on other things. Mm-hmm. Like
not bad for 2 hours of work.
Exactly.
Great.
Yeah.
I feel good about this list too.
Yeah, me too. Mm-hmm. It passed 3 filters anyway. Were they great? Moya, what are you working on? What can people find out more?
You can find me on the interwebs at GoAstroMo on all the socials and moyamctier.com if websites are your thing. I host 2 podcasts. One is called Exolore about fictional world building, and one is Pale Blue Pod about the universe, and we will have Fraser on it very soon. And right now, most of my time is spent writing my second book to be published, which is going to be a history of invention and a commentary on, like, what does it mean to be a genius? And it's coming out probably in 2026.
Oh, that sounds great.
Thank you.
Dakota.
Yeah, so you can follow me on all the social platforms, DT StarKid. Check out my website as well, www.dakotatyler.com. I'm a PhD candidate still, so I'm doing research. Right now I have this survey where we are looking at planets that are in these what we call disordered configurations, where usually we find that small planets are closer to the star and they get larger as you expand out. But in some scenarios, we find that there's actually a large planet interior to a small planet. And I try to, with these observations, we're trying to tease out what's happening, see if we can explain what the evolutionary track is for systems like these. And so that's an ongoing project that I have, and just doing the PhD thing. Doing some public speaking and planetarium events as well. So if you want to book me for something like that, you can check out my website.
Yeah. But follow you on the most important social network of all, which is Archive.
Absolutely.
Yeah.
Get that H-index up.
Yeah. Download my paper.
Well, it was great to see both of you guys. Super fun to do this. And I hope we have some more projects in the future. Take care, everybody.
Thank you. Bye.